All right. So the big thing is before you start these problems, you need some backstory. And the backstory is pretty much you want to think of this every time you do a problem. You want to kind of think of this little chart. And here's going to be your word problem. And your word problem, the first thing you do is say, which of these two columns does this land in? And the two options are the words direct and the word inverse. So what I can tell from these problems is most of the time they tell you this, which one's which. Sometimes you got to be able to figure it out on your own. In general, things with the direct, you need to know that the relationship means we're always going to be talking about two things. And as one thing goes up, the other goes up, or vice versa. As one thing goes down, the other goes down. This is direct proportions, direct variations. And when you're talking about inverse, you're talking about as one thing goes up, the other goes down. Or as one thing goes down, the other goes up. So you want to make sure you're thinking about, here's a problem, which path am I taking? And then to wrap your head around it, the easiest examples that you can always remember is this one is money. So more hours worked, the more hours you work would equal more money. So as this one goes up, more hours you work, that one goes up, more money you make. Vice versa, if they both go down, they would go down together. And then this one over here for inverse, you want to think about people building a house. The more people that I have, as I add people to the job, the more people I have, the time required to complete the project is going to go down. So when you're thinking about inverse, always thinking about building a house. More people, less time it takes. Vice versa, the less people I have, the more time it would take. So then once you have these ideas, you got to say, all right, how do I use them? And there's two formulas you've got to write down and you've got to memorize. And the two formulas are y equals kx. And the other one you want to write down is y equals k divided by x. So you're going to look at these two formulas. Now, the letters are going to change based on the problem. We're going to pick letters that make sense. First off, we're always going to keep k as k. K in these problems stands for constants. And why do they use k instead of c? I have no idea. This is how I learned how to teach this lesson. It was always with the letter K. So the letters Y and X, they're going to change for each problem. We're going to pick our own Y and our own X, depending on what the problem's talking about. But we're always going to let K be K, and we're always going to fit these problems into these two formulas. So the first thing you're going to do is say, all right, I've got a word problem. Which column am I going in? Is this a direct, two things are going up or two things are going down? Or they just tell you this point blank. Most of the problems tell you it's direct or it's inverse. So some way or other, you're going to pick one of these two columns. And then you're going to fit the problem into this formula. Okay. And when you do that, there's three things you want to do. First thing you want to do is you want to make an equation, which we've already got sitting up here. You want to make an equation, and we're going to model the letters around whatever we're talking about. Second thing you want to do is solve for K, and you're going to use algebra to do that. And then the third thing you want to do is you want to answer the question. Answer the question. So you're going to get a problem. Either they're going to tell you which path you're taking, or you got to figure it out by reading what's happening. Are two things going up or two things going down? Or is it a vice versa, one up, one down, one up kind of relationship? These two examples kind of give you an idea of what they mean. And then once you get that, You pick the formula you need. If it's direct, we're over here. If it's inverse, you're over here. You want to follow these steps. The steps are, we want an equation. And again, we're going to pick our own y and our own x. We're going to pick letters that make sense for this. We want to solve for k. We want to answer the question. So before we get into the problems that are a little more confusing in the book, just pick things that are very easy. So let's continue these columns. And let's just say that it takes a second to write this out. Let's say you make $10. You make $10 an hour. And let's say during the week you worked, let's change this problem. Let's say you made $100. $100. Say you made $100 in a week, and during the week you worked 10 hours. Given that, how much would you make if you worked 20 hours? Now, this is intentionally easy. Everybody knows the answer here is going to be 200, hopefully, because you pretty quickly can just say, yeah, 100, made 100 a week, 10 hours, that's $10 an hour. No problem. You can just common sense that answer out. But when you start with a really easy one and you follow these steps, it'll make sense on what you're going to do in a little bit when you start doing stuff that doesn't make sense, right? So when I say you're going to make $100 a week, let's follow the actual pattern out of this. So the pattern says y equals k something. So let's go through this. And let's say instead of y, let's pick a variable that makes sense, like m for money. So the money you make is equal to, remember, we're always keeping k, and I don't know, what do we want to do? So something like W for wage, I don't know, or about H for hours, something like that. So start to plug some stuff in. Solve for K. How much money did we make? We made 100. So if you put 100 in, 100 is equal to K, and then H was 10. If you solve this for K, divide both sides by 10, K is equal to 10. You keep this K and we start over now. So if we start over and we say M is equal to KH, but instead of K, we know what K is 10. And we want to know how much would you make if you worked 20 hours. Now you just toss your 20 in for H, and you would make 200. So again, I get it, that's really unnecessary, and you're saying, why would I do all of that? Because we could have just done this to begin with. But if you follow the process, it'll take you through the hard problems in a second when you start seeing stuff you don't know what it means. So what did we do? We made a formula. Money is equal to KH, H being our hours. We plugged in and solved for K. 100 was our money, 10 was my hours. Came out that K was 10. K is constant. So that's the thing that's consistently the same in the problem. And in this particular problem, the thing that's consistently the same is the amount of money you make per hour. So that's our constant, 10. Then we come back up here, here's my 10. Start plugging your stuff in, you go through and you solve, you come up with 200. Okay. So we're gonna start looking at the ones from the book now. As you do that, you should have this in front of you. You're going to have a problem. Do I want to go down this path or do I want to go down that path? They're either going to tell you by literally saying direct or inverse, or you need to figure it out, 2 ups and 2 downs versus 1 of each. Once you make that decision, we want a formula. We want to solve for K. We want to answer the question. So, all right, let's see what we got here. So you got to read to me. What's the first problem we had pegged?
The
weight of boxes.
weight of outlet boxes.
So here's the thing is that as you're reading this to me, I'm going to cut you off. When you do these problems, you kind of want to just scribble the important stuff. So I'm going to write this down here. Weight, you're almost kind of like writing like a caveman here. Weight of boxes, just very quick and to the point. Weight of boxes, okay?
Proportional to number of boxes.
Proportional to number of boxes. So first thing you want to do is just figure out what kind of relationship you have. And this one doesn't, is there anywhere in the problem where it says the word direct or inverse?
No, it just says proportional.
Okay, so if that's the case, you're back here and you got to make your own decision. But common sense should tell you, hopefully, more boxes, more weight, less boxes, less weight. So that takes me down this path. So we need to pick letters that represent some stuff here. So weight of boxes, we're going to go with W. Number of boxes, we're going with N. So we've got some letters, and you need to have the formula memorized that sets this all up. So you've got this in front of you, and you say, I'm on this path, I'm using this formula. But now it says weight of boxes is proportional. So usually we're thinking Y equals KX. Well, now I'm going to say W equals KN. So weight and N, we picked letters that made sense to my problem. Okay, keep reading.
Okay, 400 boxes weigh 120 pounds.
Stop. 400 boxes weighs 120 pounds. So you just go slow, piece by piece, you start plugging stuff in. Here's my weight, here's my number. What was step 2 of my 3-step guide? Step 2 said solve for K. So we're going to solve for K. To solve for K, you would divide both sides by 400. If I divide both sides by 400, you get 41 something, I believe. It's 120 divided by, you get, no, I lied. This is 0.3. I was thinking about a different problem. You've got 0.3. Okay, the second you get K, remember, that's your constant. That's like when we were doing the money problem a second ago, that was your consistent thing. It was how much money you kept making per hour. So in this case, this is going to be the ratio of, you know, linking one thing to the next. So all you do is go back to your formula and plug that in. So now I know that W is equal to 0.3 N. Now you start reading again. They're going to give me one of these variables. I'm going to solve for the one they don't. Keep going.
Okay, we want to know how much 500 boxes would weigh.
So they just told me 500 boxes. So that means I want to solve for W. So now all we do is take the 0.3 times the 500. And when you do that, you're going to get W is equal to 150. Okay. So
Yeah.
When you're talking anything involving direct, you start with Y equals KX. Instead of Y and X, pick letters that make sense. You want to go through and solve for K. Go back in and plug in for K. Solve for whatever piece they don't give you. Okay.
That makes sense.
All right, next one. We've got number 2. What do we got for number 2? Go ahead.
50 feet of wire.
Hold on here. So we got 50. We can do the same thing. 50 feet. 50 feet of wire.
Yeah, and its resistance is 1.2 ohms.
Now we need to know the relationship between that, and I think this is more of an electrical term than a math one. So you need to tell me that more because I don't know necessarily that relationship.
Okay.
50 feet of wire,
As
1.2. How do you say ohms? Is that OHZ?
OHMS.
Oh, I meant like an abbreviation. Okay, OHMS. Okay. All right.
Okay. Now their relationship in the longer the wire, the higher the resistance.
All right, so you guys need to know that on your own. So the more of this, the more of that, right?
Right.
And the less of this, the less of that. So that's a thing where you got to know that from class. In other words, that means it's directly proportional. So this goes back to the same thing. Which path am I taking? And these problems don't always tell you that. So you got to know more wire, more ohms, less wire, less ohms. So we're on this track again, the direct one, which means I want to think about this formula right here. That's my equation. I want to solve for K. I want to answer the question. So I'm going to go with, what are we using here? We're saying we've got wire, and we've got ohms,
Resistance.
whatever you want to call it, ohms or resistance.
Call it
R.
an R, resistance, yeah.
Okay, there you go. So that's resistance. So you guys need to know these words here. I don't know them. All right, so you got resistance. All right, so the fact that it's directly proportional means we're thinking about y equals kx. So I'm thinking about w equals k r. So you've got your equation. Now you keep reading. Typically, they're going to give you a W and an R, and then we're going to solve for K. So keep reading. Tell me about wire. Tell me about ohms.
Okay, well, you've already got that. 50
Oh, we already
feet.
got it. All right, so that just answered my question. So up here, you're looking for the piece of information or the pieces of information that'll give you K. And they already told you it was in the opening statement. So 50 feet of wire is going to be W, and your resistance is 1.2. And when you divide those two out, I want to solve for K. So if I divide both sides by 1.2, it's going to give me 41 2/3, but we'll just call it 6 repeating, toss a 7 on there. That's equal to your K. As soon as you find K, you want to go back and write it in, start over. So W is equal to 41 point. And now you keep reading and see what they're going to have you solve. So keep going.
All right, now we're trying to find out what length of wire would have a resistance of 12 ohms.
Okay. So they want to have you solve for W, and they gave you the resistance value of 12 ohms. So if you want to solve this, you're just going to multiply them both out. And let's see what you get when you do that. That would be
500.
Yeah, it's 500 on the dot. So W is equal to 500. Okay. So both of the first two problems we looked at were things that were directly proportional. It followed y equals kx. We solved for k. We plugged that back in, solved for the thing they asked you to. They give you an additional piece of information. All right, so we're probably ready to look at something that is inversely proportional, I'm guessing. So let's look at the third one. And what do you got for the third one?
Well, let me see here. 10-inch pulley.
I think we're looking for rotation speed.
Okay. The rotational speed.
All right, hang on. I got it right here. Rotation speed.
Is inversely proportional to teeth.
Inversely proportional to the number of teeth on a gear, right?
On a gear, yeah.
You want to take whatever paragraph they give you, just like we've done in the last two, and just pull out the big pieces of information. Thing one, thing two, what's the relationship? So thing one, thing two, here's my relationship. It's inversely proportional. So same deal. You still want to pick letters. R for my rotation, T for my teeth. And I want to make an equation. So now this goes back to the opening page still. You got to have these notes to get through this. It's which path am I taking? So word problem, I'm going inverse because it told me that. That means one up, one down. What's the formula for an inverse problem? Y equals K over X. So we're going to take that and say, instead of Y, though, we got R. So R equals K over T. Okay, we keep going. We want to solve for K. Means you need to give me some numbers.
Okay, we have 50 teeth at 2,000 RPMs.
50 teeth, and it's turning at would you say 2,000 or 200?
1,000.
Okay, so now we got that. I want to solve for K. K is being divided by 50. So if you want to solve this for K, I'm going to multiply both sides by 50. If you multiply both sides by 50, it's going to give you 100,000. 100,000 is equal to K. It's the same thing we did in the direct problems. You're just working with a different formula, but I want to go up and I want to toss it in. If I do that, now we have R is equal to 100,000 over T. Same thing, keep reading. They're going to give me one of these pieces of information. They're going to ask me to solve for the other. Keep going.
Okay, we want to know what the RPM is for 200 teeth.
So they gave you that. So now you would go in your calculator or wherever and you would type these in and you're going to come out with 500.
500, that's right.
Make sense?
Yes.
Okay. So
Let's do one more, huh?
yeah, we can do as many as you want. So
Cross section, let me find it. Oh, darn. Okay,
all right, what do you got?
you have 1,000 feet of wire is,
I'm listening.
oh, wait, I'll get you messed up. Okay, a number 10 wire has a resistance of 0.9989 ohms for 1,000 feet.
Wire has a resistance of, what'd you say?
0.9989 ohms
Okay.
for 1,000 feet. And it has a cross-sectional area of 10,380 circular mils.
Of 10,380?
Yes.
All right, so you told me two big things here. The problem with these things is you just get so many words that you don't need. The big things I heard you say was the word resistance and cross-sectional area. So what's the relationship between these two things? Does it tell you?
Okay, they're inversely proportional.
It tells you that, right?
Yes.
So again, it's the same thing. It's just more words, more stuff you didn't need to hear. You need to take whatever paragraph, whatever problem they give you, you're looking for thing one, thing two, and what's the relationship between them. And the second you can map that out, it's the same problem on repeat over and over and over. It's just a matter of saying, what are my two things? What's the relationship between them? And then once you have that, you're right back to this piece of paper and you go through the problem and say, here's my equation, solve for K, answer the question. I'm going to use one of these two formulas. So we're looking at resistance and we're looking at whatever, A for area or whatever letters you want to use, it doesn't matter. And we know it's inverse. So I'm going to say R equals K over A. All right, and then we need to solve for K. So somewhere they got to tell you information and it was already given up top. They gave me a resistance, they gave me an area. Okay, so that's 0.9989 is equal to K over, what do we got, 10,380. If I want to solve that out for K, I'm going to multiply both sides by 10,380. So if we take that and then times that, you would go into your calculator And that should give you 10,368.58. I don't know how many decimals you're using, but that should be close enough.
That's good.
All right, that's your K. So now we want to go back, same deal. We want to toss it in. So now we have R equals 10,368.58. So we're right back to here, but we solved for K. Now you read the question. They're either going to give me resistance or they're going to give me cross-sectional area, and they're going to have you solve for the other one. So what do they give you?
They give you cross-sectional area of 5,178.
Okay, and then they ask you what would the resistance be?
Yes.
Okay, so you toss it in and you solve. Then you need to go fire that all into a calculator, and I don't have the answer in front of me. I need to get my
Will
calculator.
come out to be 2.0024.
2.0024. Yeah, so you obviously need a calculator for that, and you just type them in, and that gives you your answer. Okay.
Really works out better than that cross multiplying.
Well, it's not that the book's wrong. They are cross multiplying. They're just not explaining to you why. In other words, they're giving you this right here. They're giving you this. They're giving you this right here. They're just not showing where it's coming from, right? So it's not making any sense. If you sit there and you start back at the beginning and you add a little bit of structure to it, in other words, back up a step or two and go through and say, what kind of problem am I doing? And then walk your way through it, you're going to land at the same math they're doing. They're just not giving you any backstory. They're just starting you off in the middle of this with no explanation, right? So now there is one more type of little twist they can throw at you here. And in other words, our 3-step problem said equation, solve for K, get me an answer. There are problems every now and then where the answer to the question is K, right? So in other words, like a little bit ago, we had a problem that said wages was equal to K times T, and this ended up being what you made per hour, or instead of calling this wages, let's call this just money. I'll make it sound better. So money is equal to K times T. So, and when we did the problem, I told you, I forget what we did. I think I said $100 was equal to K, and it was 10 hours. And then there was more to the problem, and it said, given this information, yada, 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 yada. Well, the problem could just say, hey, how much do you make? How much do you make per hour? If that was the case, you're not doing the 3rd step of the problem. You're not figuring out the question. K is the answer to the question, right? They're not giving you anything else to go on. Usually it's given this, okay, now use it to go find something else. If I just ask how much money you make, well, that's whatever K is, right? So whenever you come up with K is equal to 10, there's nothing else in the problem. That's the end of it. So look at the problem that says, you read one to me earlier. I put a star by it because I've seen that's what it was. That's why I saved it for the end. Let's say, where did I put it? I think number 6.
4-to-1 speed reduction.
Yeah, pulley speed reduction is the one that does this. Go ahead and read that one to me.
Okay, we have 10-inch pulley turns at 1,000 RPMs.
So that's the speed of the pulley?
Well, yeah, 1,000 RPMs.
All right, speed of the pulley. All right, that's one thing. What's the other thing?
They want to know the speed of a 4-inch pulley.
I'm looking for the relationship here. What are the 2 things in the problem? We've got pulleys, and then what's the other one? Ratio of something?
Oh, it said a 10-inch pulley drives a 4-inch pulley. What is the ratio of the diameters? And that's 2.5.
10-inch drives 4-inch. So when you, I mean, this is just a little bit of side information and that problem. So if it's a 10-inch driving a 4-inch, that's a 2.5 difference between them. But I keep reading the problem. Let me see what they get here.
He said the 10-inch pulley turns at 1,000 RPMs.
Okay.
What is the speed of the 4-inch pulley?
What's the speed of the 4-inch pulley? All right. So I'm trying to make, so would it make sense to say that the ratio or the speed of the pulley is, and then we're comparing it to the ratio of the diameters, right?
Yes, 2.5.
And what's the relationship to this? Does it tell you it's inversely or direct?
Doesn't tell you. But as one turns faster, the other one would have to turn faster also, so it would be direct, right?
I'm trying to wrap my head around the problem because I don't have it in front of me, but yeah, that would seem to make sense here. We have two things here, the speed of the pulley and the ratio of the diameters. And it says the speed reduction, what do they want to know? The speed reduction is what?
Now they want to know the speed of the 4-inch pulley.
We already did that. That's 2.5, right?
Well, no, they want to know the RPMs. If the 10-inch pulley is going at 1,000, what will the 4-inch pulley be doing? How many RPMs?
I think I'm looking at a different problem than you. Hold on, I'm sorry. Yeah, we're looking at two different problems.
Well, I'm on the last one.
Yeah, we're looking at two different problems. I'm sorry. That's not the one I want. I want the one where it's talking about the ratio of pulley speed. Speed reduction, ratio of pulley speed. The problem you're reading me is going to work out real nice. Direct variation, no problem, easy to go.
All right, yeah, I'm sorry. Okay. It tells you they're inversely proportional. Speed
Yeah, let's start over
is
here.
inversely proportional to the diameter.
Yeah, hold on here. Let's just take a breath. So that last one you were doing, go ahead if you want to pause this in class or whatever and work it out. That's going to be a direct variation between the two. No problem. It'd be the same thing that we had been doing.
Yeah, and it's 2,500.
Yeah, the one that I mentioned to you is this is one where it's going to be slightly different. They're going to mention it just solving for K. All right, so read this to me again. What do you got?
Okay, ratio of pulley speed is
Ratio of pulley speed.
Inversely proportional to ratio of diameters.
And that's what's given in the problem, right?
Yes.
All right, so we need to make some letters here. So they both say ratio, so I don't want to do that. So I'm going to go with speed, and I'm going to go with diameter. So you should be able to take this and make a formula that says speed is equal to K over D for diameter. All right, keep reading. What do you got?
All right, now the speed reduction required on a belt drive is 4-to-1.
Stop. Speed reduction, speed, anything involving the word speed means they're giving you S. And you just told me that number is 4, right? 4-to-1, that's
4-to-1, yeah.
So that means 4. So 4 is equal to K over, what do they give me for the ratio of the diameters?
They say if the drive is 4 inches in diameter, what size would the driven pulley be?
If they said the word diameter and they said the word 4, right?
Yeah.
Okay. And immediately they're hopping to the end of the problem, right? There's no other numbers given, correct?
No, that's it.
So when you run out of information and all they give you is one set of numbers, the only thing you're solving for is K. So if I want to solve for K, I multiply both sides by 4, and the answer to your problem is 16. Now, in all the other problems, it would say, yeah, given this information, find, and then you would go back through it again and say, instead of K, though, we know that's 16. And in every other problem we had done, it would say, yeah, now given this, find the ratio of the pulley speed when the diameter is 8, whatever. And that'd make your answer 2. But whenever they cut this off and they don't give you any more information to use, there's no other, there's nothing else in the problem. You just stop, you solve for K, everything's over. So when you're looking at these, it's still the same problem on repeat. You're going to sit there and say, which column am I taking? It's a word problem. Does this problem tell me the word direct or inverse? If it doesn't, you got to figure it out, or you need to know it. 2 ups or 2 downs, or 1 of each. And then once you have that, you have a formula that ties into each one. K is always K. And instead of Y and X, you pick letters that make sense for Y and X. You make an equation, you solve for K. In 90% of the problems, there'll be an additional piece that's now given this information, figure out something, and you go through and you plug in and you get it, unless it's the very last problem, at which case there isn't a last step, and solving for K would do it. But when you do them, it's really just a matter of reading each problem, finding thing 1, thing 2, and the relationship between them. And the harder these problems get, it's not really that they're getting harder, it's just that they're adding more words to it. So like when you look at that one a second ago about cross-sectional area, that problem wasn't any harder. It was actually probably one of the easier ones. It was just a matter of figuring out wire has a resistance of this per foot, all these words. The only word you needed was resistance. And when you get over to here, cross-sectional area of something, 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 all you needed to know was 2 words: resistance, area, inverse. And when you break it down into very simple words and a relationship between them, you're going to do the same problem over and over and over. It's just a matter of reading the problem, pick out one thing, pick out a second thing, put a relationship between them, either because they tell you or because you already know it. Cool?
Very good. Makes sense.
All right, I'm going to turn this thing off. Hold on.
All right. Thank you.
Yep, got it.